Hey everyone! Welcome to Space Science Simplified. Today, we're diving into one of the wildest and most mind-blowing topics in the universe. What happens if you fall into a black hole? Buckle up, because this is going to be a journey across space, time, and the very edge of what we know about physics. Let's start with the basics. Imagine a place in space where gravity is so strong that nothing, not even light, can escape. That's a black hole. It's like the ultimate cosmic trap. But how do these monsters form? Most black holes are born when huge stars run out of fuel. Without the energy to fight gravity, the star collapses in on itself, squeezing all its matter into a tiny super-dense point called a singularity. Around this singularity is a boundary called the event horizon. Think of it as the point of no return. Once you cross it, you're not coming back. Black holes actually come in a range of sizes. Some are known as stellar black holes, which form when massive stars collapse at the end of their lives. These typically have a mass a few times greater than our sun. And also there are supermassive black holes, which are millions or even billions of times heavier than the sun. These giants are usually found at the centers of galaxies, including the one at the heart of our own Milky Way. All right. Let's say you're in a spaceship, heading straight for a black hole. At first, everything seems normal. But as you get closer, things start to get weird. Gravity gets stronger and stronger. If you're far away, you could orbit the black hole just like planets orbit the sun. But as you get closer, you'd see stars and space start to warp around you. Light from behind the black hole bends, creating a glowing ring called the photon sphere. It would look like space itself is being stretched and twisted. Now you're getting close to the event horizon. This is the invisible boundary around the black hole. Once you cross it, not even light can escape. To an outside observer, like your friend watching from a safe distance, you'd appear to slow down as you approach the event horizon. You'd get dimmer and redder, and eventually, you'd just fade away. But from your point of view inside the spaceship, you'd cross the event horizon without noticing anything special, at least at first. Here's where things get intense. As you get closer to the black hole, the difference in gravity between your head and your feet gets huge. This is called tidal force. If you're falling in feet first, your feet are pulled way harder than your head. The result? You get stretched out like spaghetti, a process scientists literally call spaghettification. In a small black hole, this would happen before you even reach the event horizon. You'd be pulled apart atom by atom. In a supermassive black hole, the tidal forces at the event horizon are weaker, so you might actually cross the event horizon in one piece. But eventually, as you get closer to the center, spaghettification is unavoidable. Okay, so you've crossed the event horizon. What now? Well, inside, all paths lead to the singularity, the center of the black hole. There's no way out. Space and time are so warped that every direction, even up, leads you closer to the center. What happens at the singularity? Honestly, we don't know. Our laws of physics break down. It's a place of infinite density, where the known rules of the universe just stop working. Some theories suggest you'd be crushed to an infinitely small point. Others think maybe something even stranger happens, but nobody knows for sure. So what do you think? Drop a comment below. Here's something really trippy. Time itself gets weird near a black hole. The closer you get, the slower time moves for you compared to someone far away. If you could look out at the universe as you fell in, you'd see the outside world speed up. Stars aging, galaxies spinning, maybe even the end of the universe, all in fast forward. There's a huge mystery in physics called the black hole information paradox. When you fall in, what happens to all the information about you, your atoms, your history, even your memories? Does it disappear forever? Some scientists think it might be stored at the event horizon, or maybe even released back into the universe as the black hole slowly evaporates over billions of years through something called Hawking radiation. But this is still one of the biggest puzzles in science. Let's imagine your experience as you fall in. First, you'd notice the stars behind you start to stretch and swirl, thanks to the way the black hole bends light. As you get closer, the black hole would look bigger and bigger, eventually filling your entire view. The universe outside would shrink to a tiny bright spot behind you. If you tried to shine a flashlight ahead of you, the light would never escape. It would curve back and spiral into the black hole with you. Even radio signals or messages you tried to send back home would be lost forever. And here's a wild thought. If you fell into a supermassive black hole, you might not even feel anything at the event horizon. You'd just float right past it, completely unaware you'd crossed the point of no return. But as you got closer to the singularity, the tidal forces would ramp up fast, and then spaghettification. Not all black holes are created equal. In smaller black holes, you'd be torn apart before you even reach the event horizon. In supermassive black holes, you'd get much closer to the center before gravity finally wins. And if you fell into a spinning black hole, called a Kerr black hole, things get even weirder. The math suggests there might be a way to avoid the singularity or even travel to another universe, but that's deep into science fiction territory. Let's flip perspectives. What if you're watching your friend fall into a black hole? From your point of view, their fall would slow down as they got closer to the event horizon. Their image would get redder and dimmer, stretched out in time, until they seemed frozen in place, never quite crossing the line. But for them, the fall would feel normal, until the very end. Let's get creative. Suppose you strapped a camera to your helmet and tried to record your fall. You might hope to capture some epic footage, but unfortunately, the camera would face the same fate as you. As you got closer to the event horizon, the camera's signals would get weaker and weaker, stretched out by the black hole's gravity. By the time you crossed the event horizon, no signal would ever make it back out. Your last moments would be lost to the universe forever. But if you could somehow watch the footage from inside the black hole, you'd see the outside universe speed up insanely. Billions of years could pass in what felt like seconds for you. You might even see the universe end before you hit the singularity. Black holes aren't just cosmic vacuum cleaners. They're places where the rules of the universe get rewritten. Scientists use them to test ideas about gravity, time, and even the possibility of other universes. Some theories suggest that black holes could be gateways to other dimensions or even act as time machines. But right now, that's all speculation. So, the big question, could you survive? Short answer, no. If you fell into a black hole, you'd be stretched, squished, and eventually crushed by gravity. There's no way to send a signal back, and you'd never escape. But the real story is even more fascinating. It's about how black holes challenge everything we know about space, time, and the universe itself. So, why do we study black holes? Because they're natural laboratories for the universe's most extreme physics. They help us understand gravity, the life and death of stars, and maybe even how the universe began and will end. Plus, they're just plain awesome. If you enjoyed exploring this cosmic mystery with us, don't forget to subscribe to our channel and drop a comment below. Let us know your thoughts or what space topic you want to see next. Thanks for watching, and remember, never get too close to a black hole.